Hello guys, welcome to our channel once again. Um, for today, we are going to continue our lecture on measurement in physics. We've done measurement in physics using the Vernier caliper. Now today we'll still continue with measurement in physics, still using the Vernier caliper, but in a different way. Today, what we're going to learn today is how to measure zero error on a Vernier caliper. How to measure zero error on a Vernier caliper. Before we do that, please, if you have not subscribed to this channel, please subscribe to this channel. Give us a thumbs up if you like what we're doing so that you can encourage us. Also, invite your friends. Yes, invite your friends and tell them that something good is happening in YouTube. Tell them to subscribe to our online classes. And then if you have any question, please put them in the comment section below. Then click on the notification button so that when we upload any new video, YouTube will notify you. Our class, this is what I said we're going to learn in this particular class for today. So for this class, we're going to learn measurement of zero error on a Vernier caliper, or measurement of zero error on a Vernier scale. Okay, so how do you know that your Vernier or your Vernier scale has zero error? There's one way you can know, and that is if you have your Vernier caliper, just close the joints together. Normally, in a Vernier scale that doesn't have a zero error, when you close the joint together, the zero on the main scale will coincide with the zero on the Vernier scale. But if you close the joint together and the zero on the main scale or on the Vernier scale does not correspond with the zero on the Vernier scale, then that your Vernier has a zero error. Now, if it has a zero error, how do you determine that zero error? That is what this class is going to teach you today. How to determine the zero error on a Vernier scale. Now, your zero error on a Vernier scale can either be positive or negative, depending on the side the zero on the Vernier scale is to the zero on the main scale, right? Depending on the side that the zero on the Vernier scale is to the zero on the main scale. Okay, this is what I'm trying to see. If the zero on the Vernier scale is to the left, that is, if it's to the negative side of the zero on the main scale, look at this one. This zero here is on the left of the zero on the main scale. So if your zero is on the left of the zero on the main scale, the zero error on this particular Vernier scale is negative. So your error calculation will be negative, right? Then if the zero on the Vernier scale is to the right of the zero on this main scale, then your zero error will be positive. Now, this is the calculation. This is how you calculate the zero error when your zero on the Vernier scale is to the left of the zero on the main scale. This is how you use this is the formula that you use to get your zero error. What you do is that you know that the Vernier scale is graduated to 10 millimeters. So what you do, whatever reading you have, you subtract it from 10 and then multiply by the accuracy of your Vernier scale. Don't forget that the accuracy of your Vernier scale is 0.01 centimeters. So what you do is that, like for this particular one, for this particular scale, see the zero is to the left, so which means this will be negative, right? So now you look at the line or the mark that is on the Vernier that coincides with the mark that is on the main scale. If you count here, you see this is 1, 2, 3, 4, 5, 6, 7. If you look at this mark very well, this is the one that corresponds with the mark on the main scale. So which means that for this particular scale, what you now do is that you subtract that 7 from 10 using this formula. 10 minus 7 gives you 3. Now multiply 3 by 0.01 centimeters. That gives you 0.013. I mean 0.03. So what you have is negative 0.03. That will now give you the zero error for this particular scale reading that you are seeing now. Alright, so this is what you should have. This one you should have 0. minus 0.03 centimeters. That will be the zero error for this particular scale that is here. Now, assuming your zero is to the right, so I've said that once your zero is to the right, if the zero on the Vernier scale is to the right of the zero on the mean scale, your zero error is positive. So in this case, what you use is that you just take your reading normally. You take your reading normally on the Vernier scale, then multiply it by the accuracy of your Vernier, which is 0.01. So like in this case now, you just look at the mark that is on the Vernier scale that coincides with this one on the main scale. That will give you the reading or your zero error. Multiply it by 0.01 centimeter, and then you have your reading. So if we look at this one, you have this is 1, 2, 3. So here 3 is the mark that coincides with the mark on the main scale. So multiply 3, so which means your reading is 3. Multiply 3 by 0.01. That gives you the zero error for this particular scale. So basically, measurement of zero error in a Vernier scale is easy. So once you have known how to take the reading of a Vernier scale, to get the zero error is quite easy. It is quite easy. So right now we're going to do some examples so that we'll still drive home the points. So this is a Vernier scale, and we are told that the joints of the Vernier scales are closed firmly. However, the readings are not exactly zero. Determine the zero error and then state whether it is positive or negative. Now, I've told you how to know whether it is positive or negative. When the zero on the Vernier scale is to the left of the zero on the main scale, then your zero error will be negative. But if it's to the right, your zero error will be positive. So basically, like what we have here now, this zero error is positive. Now, how do you read it? You look at the mark that is on the Vernier scale that coincides with the mark on the main scale. That will give you your reading. So like here you have, this is 1, 2, 3, 4, 5, 6, 8, 9. So this 9 is the mark that coincides with the mark on the main scale. So that gives you the zero error. So the zero error, multiply that number, multiply the 9, right? Multiply it, the 9 millimeters, okay? Multiplied by 0.01. So that gives you centimeters. So that gives you your answer is that gives you plus 0.09 centimeters. So that gives you the zero error for this particular scale. Okay, similarly too, if you look at this one, you see that in this particular case, the zero on the Vernier scale is to the left of the zero on the main scale. So this one will give you a negative answer. Now what you now do is that you look at the mark here that corresponds to the mark on this main scale. That will give you the reading. Then you will now subtract whatever you have from 10, as we did in the previous example. Subtract that one from 10 and then multiply your result by 0.01 centimeters. So here you have, let's look at it. This is 1, 2, 3, and 4. So okay, this is 4. is 4. So for you to calculate your zero error, you have negative that. Okay, that is negative already. So you have 10 minus 4, right? Whatever you have multiplied by 0.01 centimeters. So this will give you minus 6 times 0.01 centimeters. So that will give you your answer to be minus 0.06 centimeters. So for this particular scale, this will be your answer, minus 0.06 centimeters. So you see the variation between the two. In this case, the 0 is to the right, while here the 0 is to the left. To the right you have a positive 0 error, to the left you have a negative 0 error. Okay, one more example here we can look at. Okay, if you look at this one very well, look at them, though the 0 they are close, but for this particular one, the 0 on the Vernier scale is still to the left. Is to the left of the 0 on the main scale. So this one automatically tell you that the 0 error is a negative. So what you now do is that look at the mark that is on the Vernier scale that correspond to the mark or the main scale. So if we look at it, we have 1, 2, 3, 4, 8. The 8th mark corresponds to the mark on the main scale. So you do your calculation the way you did for this one above. You write minus 10 minus 8 multiply by 0.01 centimeters. So whatever you have there, you have minus 2 times 0.01 centimeters. Okay, so that gives you your 0 error to be minus 0.02 centimeters. So basically, I think this is really quite simple and easy, but it's a little bit trickish, but it's quite easy and simple. So this is 0 error for this particular scale. This is the 0 error for this particular scale. All right, so we'll go straight away to your test your understanding. So please, this is for you to do test your understanding. I've always said I will be giving you tests to check your understanding and comprehension. So for each class that we have, I must give you a test to check your understanding and comprehension. And this test, please, I've said, don't take it lightly or trivialize it. Answer your review questions. Put your answers on the comment section below, or click on the WhatsApp link and then put your answers on the WhatsApp chat group. I will respond to all your comments and to all your answers. I will respond to all of them. So guys, this is where we are going to end our class for now. I always said that please make sure that you take down your notes and then do the examples. Also invite your friends so that they can come and enjoy what you are enjoying on YouTube. If you have a friend that loves physics and want to learn, invite them. Tell them to you have seen something in YouTube that they want them to also enjoy from. Subscribe to our channel and then click on the notification button. Whenever we upload a new video, YouTube will notify you that a new video has been uploaded into Noble Minds Tutors online learning class. So thank you so much for your time. Also give us a thumbs up if you like what we are doing, and then invite your friends. We'll see you in our next class.